2008 ADM grain elevator project, and my name's Wade Miller.
Chris Allen.
Matt Gillespie. Jeremy Holscher. Bill McQuinn. Dwight Ludwig.
Wade, we've got this miniature elevator here. What's the overall essence of the project?
The essence of the project was to create a model that ADM can take to their yearly meeting with the CEO and all the different divisions of the ADM company. And they wanted us to create a project, a model that would show the flow of grain and how it works, so they could demonstrate to the rest of the company what the grain division does.
Matt, I see we've got clear hoppers, a conveyor. Explain the flow of the grain in this miniature elevator here.
All right, we're just going to basically have 2 of our 4 bins full, and we're just going to cycle the grain all the way through the elevator, and it's going to come through our bin gates here onto the conveyor, into the leg. The leg's going to take it up and drop it down into the auger, and then from the auger we can fill any of our 4 bins.
So we're going to have sample of belt conveyor, leg conveyor, auger conveyor, hopper flow of corn or soybeans.
Yeah, we're going to use corn.
Excellent.
All corn in it.
Dwight, it looks like we've got lots of electronic controls here. What are we connected to in the whole system?
The main power feed. The main power is coming from a generator we have out there. It runs electricity in here. When it runs into this box, goes to each different component. And we operate it with a touch screen here in front of the box.
What kind of sensors do you have involved?
We have slow down sensors on all our bearings to monitor the speed of the belts, temperature monitoring in each bin, position on our gates.
Bill, I see that we have a lot of see-through components on this miniature grain elevator. What's the purpose of all this Lexan?
Well, the Lexan is so you have the see-through material, and this, where you have the Lexan right here, is normally going to be covered by metal. So this is going to allow you to see the flow of grain, how the leg picks up the grain, which is normally not going to be able to be seen. We also have Lexan over the top of the belt conveyor. That way you can see as the grain flows through the hopper onto the belt, you're going to be able to see it, as well as back here where it flows into the leg, how the buckets are going to pick it up. And when it goes through the leg, it's going to come out into the clear plastic Lexan tubing, which is going to have our auger in it. So you'll be able to see the flow of grain the whole way through.
This looks like one of these watchdog systems in a regular elevator. What kind of sensors is it connected to, and how does that relate to the real world?
All right, this is our watchdog sensor, obviously for our leg, and it will be taking care of the bearing temperature monitors and the alignment sensors, which are right here and also on the top of the leg. And what these do, the alignment sensors will let you know if your belt is actually in line, and if the belt comes out of line, the belt will rub against these sensors and send an emergency back to the watchdog system, which will there will be a time delay, and if it's rubbing onto the sensor for a specific amount of time, it will actually shut the leg off. And it's basically the same concept with the temperature monitors. If something goes wrong, if the temperature's too high, it'll send a relay back or an emergency, and if the problem persists, it'll shut the leg off.
I see lots of Lexans and bears. What do we have here?
Well, our main goal is to get everything that's in a large-scale elevator into a small-scale elevator. And as you can see, we got hoppers, we got an auger, we got belt, conveyor, grain leg, and all the wiring for it, actuators and touch sensors, rub sensors, bin temperature cables, just about everything, just like a real elevator. I think that's what we were going for.